All right. Well, thanks everybody for having me here. It's great to be here. So yes, I'm going to talk about native mobile performance, which is sort of niche, like people have never had apps before. But I get it, web performance, you know. But let's talk about this, and then and the trick is a lot of people that I've spoken to are like, well, I don't really know what my app is doing. It's sort of a black box, and I want to show you some techniques that we have out there to probe into the performance of your native apps so that you can make them run better, because we all know that apps that run better do better in the market. And you may have heard of mobile. Mobile's kind of a big thing, whether it's web or it's apps. I went and found a few stats just from last month, but on Christmas Day, John Lewis had 75% of all their traffic was mobile. Amazon said that during the Christmas season, 70% of all their shoppers were shopping on mobile. A lot of people are going there. They're doing a lot of stuff on mobile. It's really a big deal, and web or native, it's something that we all should worry about. But there are some worrying trends. This is from the HTTP archive. And as you can see, mobile websites are getting bigger. They're doubling about every 2 years. That's about where it looks. And where this is about I think this was 900, almost a megabyte is the median. Oh, I went ahead one. I'm doing an Ignite talk this weekend, and I think this is one of the slides from that, so it might just be forwarding on because it's every 15 seconds. But you can see like the 70th percentile is way up here at like 1.8 megabytes, which is pretty darn huge. And then you start thinking, well, everybody's on 4G, but then they're not. Maybe in North America, which is the green line, but for the most part, there's not a lot of folks on 4G. So we're building these ginormous websites and these ginormous apps that really look awesome for us on our awesome phones and our awesome 4G. But for most of the world, whoops, there we go. We're not quite there yet. So that's something to keep in mind, is that we're building these pages and these apps that are getting a lot bigger. And of course, when you use a lot more data, they start up slower. And this is a study from last year showing that 50% of people expect their app to start up in 2 seconds, and 91% expect it to start in 4 seconds. Another stat that I saw when it comes to app size is this is an ad company, and they found that when they're advertising off apps and people go to the Play Store, the Apple Store to download them, they get a lot fewer conversions. It's half. Whoa, all right, that's annoying. All right, you get half the number of conversions when your app is over 50 megabytes versus 0 to 5. So people are actually seeing the app size and they're like, oh, I don't want to download that. That's huge. I don't have a space, or I don't want to pay for the data, or whatever it is. People generally, if there's an ad, they're looking at the size of the app and they're deciding whether they want it or they don't want it. So that's something to think about. I didn't see anything on like usage of apps, but I saw this stat at Velocity in Amsterdam, and this is an updated slide. But when it comes to data on mobile, for us in America or in the UK, it's pretty cheap. You drop a couple pounds and you get a gigabyte here or there. But in Mexico, people have to work 42 hours. They have to work a week at minimum wage to buy 500 megabytes of data. And, we can blow through 500 megabytes of data pretty quickly. And so you have to be really careful. People are actually, that's one of the reasons why people aren't using apps or they aren't using mobile as much, is because it's out of their price range. And that's pretty significant. I mean, even India at 17%, when you think about the next billion people coming online are all going to be on mobile, and then you start thinking about the cost of mobile data, that's something to be concerned about when you're building your apps. So that brings us to the next question. Is your app a bad app, or is it a good app, and how can you find out? And it really comes down to testing. And I talked to a lot of developers and they're like, testing? So, that's part of it. But Perfecto Mobile did a study, and they found that 44% of all issues are reported by users. And that's kind of not what you want to have happen, especially when 20% of the issues are only found because of complaints in the app reviews, where your prospective customers are going to find out if they want to download the app, and then they go and they read the reviews that the app crashed, and then they decide not to download it. And so it's like this negative cycle that you don't want to have happen. And so this is the library app that I have back home. And whenever I try to log in on my phone, it crashes. And so I can't place holds on books. And that's really annoying. And if you go into Google Play, lo and behold, over a year ago, every time I try to log in, the app crashes. It still does that, by the way. I tested it last night. It's a little frustrating, especially when you're out with friends and they're like, you should really read this book. And you're like, I'm going to put it on hold at the library, crash. Because you never remember the title of the book the next day. So let's talk a little bit about performance and things we can look at. I'm going to talk a little bit about network connectivity in this presentation. I'm also going to talk about memory, and I thought I circled it. I did circle it, but my animation is out of order. All right, I win at PowerPoint today. I'm going to talk a little about memory issues. I'm going to talk about network connectivity because that's sort of more WebPerfy. And then, I wrote a book for O'Reilly that came out last year, High Performance Android Apps, where I talk about CPU and screen rendering and battery life and a bunch of other stuff. But let's talk a little bit about Android memory. And so Android obviously is running on, it's a Java virtual machine, and it's got its own garbage collector. And you think, well, why do I have to worry about memory? Memory's all taken care of by the JVM, and it's all good. And there's some great talks out there from like Google I/O where they go through all of this, and they have similar connections like this. But if you think in the upper left-hand corner, that ball is kind of like the root memory object. What the app does, what the JVM does is it goes through and tries to find things that are connected to it. And if there's a memory link, if there's a linkage between the different objects, it keeps them in memory and it doesn't clean them up when it does a garbage collection. If something is not connected, it cleans it up and takes it out of memory. So that's, that's really helpful. So if, for example, that connection went away, the garbage collection would come along and say, oh, we can get rid of all those. And they would go away just like that. And you can see there's tools like an Android Studio where you can see the dark blue is how much memory is there, and then the light blue is sort of an allocated free space, and you can see it. The memory grew there about a third of the way in, and then more memory was allocated, and it did a garbage collection at the same time, giving a whole bunch of free memory right there. But I wrote this app because I wanted to write an app that had a memory leak. And so what this app does is it connects to an image to the main activity of the app, and it connects another one. Every time I rotate the screen, it adds another image because that was a really easy way to do it. And another one, and another one. And that's what the screen looks like, right? You can see it keeps putting a new free space, and then I fill it up, and it keeps doing more and more free space, and eventually you crash it. And so that's a memory leak. And memory leaks are really, really hard to find when they're not 2 megabyte images that keep getting loaded into your app. So every time you rotate the screen, it's 2 megabytes added to the heap. I mean, they're hard to find, but they lead to a lot of crashes, and so that's something that you're worried about because of these, because of the way the app is built, you can't get rid of these memory leaks. And so how do you go about finding them? Well, you can look through the logs, and if you look in here, it's sort of hard to see, but you can see that when there's a garbage collection, that's these long lines right here. You can see it went from 112, and then the next one. The app was called the Titanic, and so every time I had a memory leak, I hit an iceberg. And so it writes that to the log, and then it does another one, and it goes up to 102, and then 108, and then eventually it runs out of memory, and the whole thing crashes. And it's easy when it's 2 megabytes at a time, but when it's a slow trickle over time, it's really, really hard to find these. And so anyway, there are these tools. There's one, the Eclipse Memory Analysis tool. That analyzes heap dumps. So you have to test your app, and hopefully you collected it in the heap dump, and then you run it, and then you run a heap dump. You dump the memory, and you do an analysis of it, and you have to learn this tool, which is a pain in the butt to use, and it's really, really hard. And I had just written the whole chapter on how to do that in my book, and then Square came out with Leak Canary, and Leak Canary is like the most awesome thing if you have a memory leak in Android, and it's up on GitHub, and it's really easy to use, and it does all the work that Matt does just by playing around with your app, and so you don't even have to deal with it, and it finds it automatically. And Square started using the tool to find the memory leaks in their app, and Square is swiping cards, and I guess they swipe in this. I don't know if they have a chip reader here in the UK. we're in America, we swipe everything still. It's old-fashioned. But you know, if the app crashes while you're doing a monetary transaction, people never know what the heck's going on. Are you charging me twice? Or that people get paid? And so memory leaks were really bad. And they found that when they did this, their out-of-memory crashes dropped by 94%. And that's pretty darn huge. And so I thought this was a great tool and I would check it out. So I'm going to do a demo and we're going to see how this works. And that's the Leak Canary thing here. So we're going to unlock the phone and then, all right, here's my phone. I broke the screen. It doesn't look like that on there, so that's really nice. So I fire up this app, and in the menu here, I have. I'm going to turn on a memory leak because that's a really smart thing to do, and then I just rotate the screen back and forth a bunch of times. I have to turn on screen rotation. There we go. Turn on screen rotation. And now when I rotate the screen, just go back and forth a bunch of times, and this is a test build. Memory leak canary is not something you want to ship in your app because it's generating heap dumps and then emailing them off to you, and you don't want to do that on your customer's phone because memory heap dumps can be really, really large. But if I sit here for a minute and I just let it sit, you'll see it'll come up and say, I'm dumping the heap, the app's going to freeze, there it goes. And then it should say up here that if it found it, of course it's not going to do it because I'm doing a live demo, but there's a leak app over here, and it shows you, oh, there it is. It might have been from yesterday, but that's okay. We'll just pretend that it's from today. But it shows you where the iceberg class that I wrote had leaked, and it tells me exactly where it is. So I can actually go into the app from this and find it should update. Oh, no, it did. Okay. So it's a great tool because this memory the Eclipse memory analysis tool would do all that, but you had this weird GUI from in Eclipse, and it was hard to figure out exactly what was going on. And this is just a library you install into a test build of your app, and you play around with on your phone, and it finds your memory leaks. And that's a lot easier. And so obviously what Square did is they gave it to a bunch of people in their building. Right? You know, they're working on these test builds, and they found all, and it can you can share the heap dumps. I hit the option menu. There it goes. So you can have this automatically go into it can file bugs into your repository with the heap dump and everything. So you get all the information you need. So as a developer, you can go back in and figure out what's going on with your app. And that's really cool because, you know, like I said, Square removed 94% of their out-of-memory crashes by doing this. And you start thinking, you know, again, our phones, the phones that I have all up here are all pretty modern, advanced phones with, you know, gigs of RAM and things, but most of the phones out there aren't those. They're phones with 512 megabytes of, you know, on Android, and they crash a lot more because they have less available memory. So that was the first time I did a live demo on that app, and so I'm glad it sort of worked. We'll go with sort of worked. So performance. This is really cool because I've been talking to folks about native performance for a few years, and it's neat to see it like that major companies are really starting to think about it, and you can actually start to see this in these are update, you know, what's new in this version of our app. And so, hey, we made a lot of performance improvements. I think that's Airbnb. And come on. That's Google Photos, and down here at the bottom, so I can't read it. The last line is performance improvements and bug fixes. Obviously, bug fixes are big, but and then the last one, improvements for reliability and speed. I think that was actually Facebook. So, you know, it's really cool to see all these applications and realizing how important the performance of their native app is to make it run faster, so that people use their application a lot more often. And so I talked a little bit earlier about crashes, and you know, you've probably seen this when your app crashes, and when you have an app on your device that crashes, what do? You uninstall it, you remove it, you look for an update, you stop using the app, you look for an alternative, you write a bad review. But when an app is slow, people do exactly the same thing. So if you build a native app and it's slow, and people are using it, they stop using it. They don't want an app that's slow. They want whatever they're doing immediately. So they'll look for another app that does the same thing. So it's really important that we make sure that our apps have good performance. And so performance really is that important. We all know that people don't like crashes, but the same thing goes for performance. And so, like I said, I've been talking to folks about performance for a while. I work for AT&T, based in Seattle. And I'm here for a couple months, and so I'm really glad you guys let me come and talk to you. But we have this free open source tool called the Application Resource Optimizer, and it's called, or Arrow. You can test your iOS, you can test Android. When we first launched it, you needed a rooted Android device. You don't need that any longer, which is really cool because a lot of developers don't like rooting their devices. Some love it. And it actually runs a network, collects a network trace on your device. Not unlike web page tests. Well, web page tests can take PCAP files. It's collecting a PCAP file. And then it grades you against 25 best practices, and you can learn all about it at developer.att.com/arrow. And so now mobile apps, really highly network dependent, right? You can't hold everything on the device. If you make a 50 megabyte app, people don't download it, especially when you update every 2 weeks and they have to download 50 megabytes every week or every 2 weeks. Or, you know, I hate it when apps want to update all the time. I actually stop using apps because they want to update all the time. I'm only using once a week. I don't need you to update that often. But it's important to know that cellular networks are high latency environments. Even on LTE, there's still about a 50 millisecond round trip time just in the network. If you're on 3G or 2G, it can be upwards of half a second. And so there's a lot of latency. And so you want to make sure that your content that you're sending over the network is optimized. Because if it's not optimized, you've got this high latency and then a further delay because your content isn't optimized. And so a bunch of studies have been done. I think this one is from, I think this was the Radware study where 500 milliseconds led to 26% increase in frustration, 8% less engagement. You know, these are old studies. This is desktop stuff, but Amazon and Walmart found for every 100 milliseconds, they lost 1% of their revenue. And that's really bad. But the best stat of all for mobile devices is that 4% of mobile devices admit to throwing their phones when they go to a slow website or app. So don't do that, or throw it at a couch. Mobile networks also drain batteries. So my colleagues at AT&T Research did a study, and they found that the data connections was 40% of the battery drain when the screen was on. When the screen is off, it's even worse. It's 70% when the screen is off because the screen is probably doing most of it while the screen is on. Yeah, obviously. Logical sort of thing. So what we're doing, this is a screenshot from the Arrow tool. And what's important to get out of this screenshot is what we're looking at is we're looking at the packets coming up, the packets going down. And then if you look at the bottom thing right there, there's sort of this yellow line. And what's important to get out of this is when you're on a cellular connection, because of that latency to open up a connection, all cellular networks keep the radio on for a period of time afterwards, so that there isn't that high latency when more packets come. If the radio's been on, there's an expectation the radio will continue to be on. And so in this case, you can see it's on for another 10 or 15 seconds after that last packet was sent. So if you watch a video, you're going to download the entire video, and then the radio's on for another 10 or 15 seconds. But if your app sends a one packet keep alive to the server, the radio doesn't turn off after that one packet is sent. The radio's on for another 10 or 15 seconds. And the timing is set by you know, network operations people in NOC, and each carrier is different, and it's different in different regions for every single carrier. It's not important exactly what the time is, 10 seconds, 15 seconds, 20 seconds, 5 seconds, whatever. What's important to know is that every time you turn on the radio, you're adding a significant battery drain. And so if you can minimize that, you're going to make your app not only faster, because all the content, well, if you're preloading stuff, it'll be there already, but you're also saving the battery and saving your customers from having to plug in. You know, you guys are probably all like this too, right? You have a charger in the car, you've got a charger at work, you've got a charger at home, you've got an emergency charger in your backpack in case you run low somewhere in between all of those places, right? It'd be really nice if we didn't have to do that. So let's talk a little bit about Aero, because obviously if we can optimize the network connection, we can save battery life, we can use less data. You know, all these things are good for our customers, and it'll make your app faster. So on Android, we do a VPN collection. And so if you think about your phone connecting to a tower and then out to the cloud, you know, I get a lot of questions like, so what's AT&T doing with this data? You've got a VPN, you're getting all of this content straight to AT&T. And quite honestly, I don't want to look at all your data. I don't have time to look at all your data, and it doesn't come to us. The VPN is actually all on the device. It's initiated and terminated on the mobile device, and then it goes out through whatever connection you're using, whether you're using Wi-Fi or cellular. It just stays. And then we collect the network traffic by probing the VPN on the device, so we don't have to see, we don't see any of the data anywhere. Nor is there any latency for people testing here because our servers are all in America or something. We don't see any of that. It's all just locally on your device. The problem we had with this, of course, was some Heisenberg, and not that Heisenberg. When you think Heisenberg, that's not the guy we're talking about. We're talking about this guy. When we first launched this, we had a lot of trouble affecting the system. We had a big observer effect. We were slowing down things a lot because of our VPN wasn't really slow. But we just launched a 5.0 beta at the beginning of December, and it's about to come out of beta probably in a couple weeks. But we had a significant delay in Aero 4.1. We had about 10 to 100 milliseconds per round trip. It was really slowing stuff down. Aero 5, we're now down to 1 millisecond or 2 milliseconds per every round trip. So it's pretty minimal at this point. I don't think we can get any faster than that. So with that, I thought I would do a live demo of Aero. And I don't know, does anyone have any apps that they want me to test? Like, does anyone have a native app that they're interested in seeing the performance of? Anyone? Throw out an app of your competitor? I don't know. That's a good one. That's how I do a lot of my testing, actually. It's like, boy, that app is annoying me, and I don't want to do it.
Who are we going to pick on? I tell you, I'm going to pick on Domino's.
Oh, all right, Domino's Pizza. I don't have that on my phone, so I'm gonna. It's giving me the US one.
Yeah.
That'll be fine. It's going to be really confused. I confuse the heck about all the apps on my phone right now. So we'll do a live demo. So you can see I'm actually, whoa. Sorry, I have this thing that.
The new multi-pizza purchasing facility that they've got.
Oh, multi-pizza purchasing. Oh, very nice. All right. So I've actually got it installed, and so this is the screencast. I'll close that, and I'll fire up Aero. Maybe. Whoa! What are you doing? All right. So this is the application resource optimizer. I'm plugged in, and so what I do. This is not a rooted device, but all I do is I hit Start Collector, and we'll see how this does. All right. So it's gonna. App has started up. So I've established a VPN on the device, and you can see that right up here. You can see the little key. So I've got a VPN. I'm recording what's going on the device. And there's the Domino's app. So we'll fire that up. Let's see what happens. All right. Delivery to a house. It's going to be not like anything like this. So we'll say we're in Seattle. I don't know. That should be good. Continue. City is required. Come on, zip code. All right. Washington. Let's see if it finds it. That's an address of a neighbor's. I don't know. We used to do that as kids. I thought that was horrible. Maybe. Do you find it that slow too? When you all right. Connection error. All right. Maybe there's not a Domino's in Seattle. Maybe we only eat hipster pizzas in Seattle. The Starbucks app. There are a few Starbucks in Seattle. I've seen those there. All right. Well, let's just. I don't think they deliver. I bet you can order it ahead of time, so you don't have to wait in line. I don't know. Settings. I don't know. Anyway, it might be interesting just to see what happened with that. The other thing I like to do with an app is kill it and then start it up again. And hopefully it's faster on the second startup. A lot of times it isn't. Oh, that wasn't bad. All right, we'll stop it. Meanwhile, I will download Starbucks because that's fun. But what's cool is now it's closed the VPN, it's copied the files over to my computer, and now I can open up the network trace and we can see what Domino's US is doing. So one thing is, currently with Arrow, we don't see the HTTPS data is a little hidden from us. So it looks like 84% is HTTPS, but we did fail some best practices. So let's see what we failed. 650K. And so we have 25 best practices. It looks like it failed duplicate content, minifying files, so removing all the white space out of the files, and then closing the connections. And we can talk about that a little bit. So let's see the duplicate content. A bunch of config files, JSON. So we can look at this file in theory. Let's see if it. Oh yes, hi, I'm Dom, your personal pizza assistant. You can say things and I will, hi Dom, I'd like to order a pizza. And so these are all, this is neat because you can see all the configurations that they've got built into the app. Now let's build your order, he says back. All right, so anyway, so you can talk to Dom. There's a DevOps joke there somewhere. You can see your loyalty. Let's see what the loyalty has to do. So they're using gzip there at least, but so these are all the questions you can ask. Oh, this is the FAQ. So the FAQ was downloaded a bunch of times. You know, it's not big. It's 1.5 kilobytes. We did have an app that was downloading this 4 kilobyte image over and over again. And one of my colleagues is like, hey, you know, you download this 4 kilobyte image over and over. And they're like, yeah, I know. And then they got a lot of press one day and there were all these downloads and the 4 kilobyte image crashed the server. So like, you know, it's the, you know, the finger in the dike, right? You want to stop the slow leak before it's a really bad leak in the future. You know, 4 kilobytes here and there, you know, 16 kilobytes here and there isn't a big deal until it breaks everything, and then it's a big deal, as are many things. So, you know, we could actually look in and see it's not there, but you can go in and look at the headers to see how long the cache headers are for all these files and see why they're breaking. Why is that file? Why is the DOM pizza assistant guy downloading that often? The other thing I notice here is this is the GPS, and the GPS was active the entire time. So it was trying to find my location to, I guess, find a pizza place near us, even though it was the US. You know, that's the sort of stuff that when you're testing outside of the area, you break it. But quite frankly, the GPS was on the entire time I was testing. It should go to yellow once it finds my location and it turns off the GPS. Obviously, that's a battery drain as well. It's not a network thing, but I've seen applications. It was a radio app, and all it needed to know was like my locality, whether I was in Seattle or San Francisco or New York. So it could figure out what radio stations were near me, but I was in a building and it couldn't get my location. And it kept the GPS on for 45 minutes while it was trying to find my location. And that's bad. You should turn that off. Build a use case in there to turn off a failover if you're not getting it. Minification. So You know, that nuance wasn't minified. Dom, the pizza dude, JSON was not minified. And actually you can see that, right? Minification is the idea that you're, so it's 16K on the network, but it was 54K once it was unzipped. But you can see it's not minified, right? There's a lot of white space in there. And if you remove the white space, obviously the file is smaller. And it will get, so was it, Andy, was it Tim who did that study where he was studying gzip plus minification to see if it made a difference? And it did make a difference, like it was a couple percentage. Stoyan, yeah. Anyway, it's even if you're doing the gzip, it still makes sense to minify it before you gzip. It does save data. And then the other one that it failed was closing connections right away. And so what ends up happening is you have a network connection, and this is one of them right here. I can just see because it's got this blue color right here. And what it is you open a network connection to do some stuff, and you don't close it. And then 60 seconds later, the phone or the network's like, hey, this connection's still open. And it sends a closed connection packet. Well, guess what? You just reset the timer. And when you reset the timer, the radio's on for another 10 seconds, 10, 15 seconds. And guess what? You just drained the battery. So, you know, I grew up in the Midwest of the United States. And when it was winter outside, we'd say, my parents would yell at me to close the door when I was, you know, coming in the house. And to save the heat, right? If you don't close the door, all the heat escapes and the house gets cold. If you don't close your connections right away, you can lead to these things where the radio's on for a longer period of time. I was gonna do Starbucks too. I'll start downloading that one. But, you know, just really quickly, this showed us a couple of things that this app could do with just, you know, a couple minutes of testing without even signing in, without even ordering a pizza. We found a couple really quick things that we could do to optimize this application to make it run faster, use less data. So that's kind of fun. I really enjoy doing stuff like that. Starbucks should work here. I've seen a few. I actually know. All right, so the Starbucks app is 44.62 megabytes. You know, I showed that slide about, you know, adoption of large APKs, and it's coffee, folks. I don't know. So it's installing. All right, so I've installed it. It's now setting up the VPN. And so we'll see my screen there. And lo and behold, there's our favorite mermaid firing up, doing the thing here. It's probably gonna want me to sign up, huh? No, I don't want to sign up. I just want to find a store near me. I love this where it starts, can you see that? It starts at 00. For a while, the Yelp app, when you signed in, if you didn't have location on, it was giving me this Vietnamese place in Ghana. So, you know, when you start thinking about data usage, we just downloaded a Google map of Africa, which is useful for people who live in Africa or who have ever visited Africa, but it's not really useful for us. We want to be up here. And I don't even know why it didn't find a store near London, right? There should be just like coffee cups everywhere. But I do have a, oh, and now I can pay with my phone, thank you. I saw I had an alert. I thought maybe it was going to tell me where there's a coffee place nearby. But it's, apparently it can't find me. Maybe I need to stand closer to a window. I don't know. Big concrete buildings, not so great for GPS. But what if I, but no, but it knows I'm here. Look, well, it thinks I'm in the Thames somewhere. That's close. Yeah, but still. Stores. Oh, it gave me one in like Stubengasse in Germany. Woohoo! And then up over here, because that's not where I am. You guys know where that is. I don't know where that is. Right. Oh, here we go. There are Starbucks in London. You can all rest easy. I don't even know what's going on. It's very confusing. All right, so we have Starbucks nearby, and it is open for another hour. We could call it, right? So anyway.
According to that, I think we were sitting in a Starbucks.
So anyway, like, I'm going to blame that on this phone not knowing where it is. I just turned it on. I didn't have, it's not getting the location, right? But sure. Gifts. I'm just curious to see. Oh, I can give people Starbucks. Order. So I guess I could order. If I were signed in and, oh, there's all this stuff. And this is the sort of stuff that I like seeing what happens with all these images. Like if I go back and I check the menu again, like, is it going to download them? Oh, okay. Well, it's cached, so that's good. But we can take a look. You know, sometimes I'll blame some of that stuff on the, I'll stop the trace and we'll see where that goes. I'll blame the location stuff on the fact that it just couldn't figure out where I was. But, you know, there's that whole use case of like, where was this phone most recently? And it certainly was not in the South Atlantic. Yelp has fixed that thing, by the way. It figures out where the phone has been recently rather than assuming that you're in the South Atlantic. Okay, so most of it was HTTPS. It did do 10 megabytes of data, which seems like a lot. This is an interesting one. So resize large images for mobile. And so what we're doing here is we're looking at the screen size of the device, and if it's bigger than 110% of the size of the screen of the device, we're failing it. We're not even looking to see. We've seen everything over the years, as you might imagine, but like 4 megabyte thumbnails. Yeah. It wasn't good. So let's see what, this might just be that big backdrop image. Let's take a look. You know, sometimes it's sprites that fail this, and like I'll give them a break on spriting, even though that's now, I guess, an anti-pattern with HTTP2, but that's a pretty nice photo. That might be like I get a lot of excuse about Retina too, right? But the thing is, if you know it's an iOS, you can figure out what kind of device it is and send the right sized image down to your users. That one was 450K. You know, it looks pretty. You know, that's where you get. That's where, as you know, I'm sure as performance guys and gals, we all get in trouble where we have to talk to our marketing, and marketing always wants the big, beautiful images, and there's obviously optimizations that need to be done there. Some minification, but obviously not a lot. You know, in general, the app isn't that bad. Let's see if we can find those. This is probably all those images. They're all sent over HTTPS, so we can't really see them. But the reason I guessed that is just you can see all of that, right? Oh, actually, no. All of that was, it was downloading, trying to figure out where I was and pointing me to the Netherlands or wherever it was pointing me to, which may have been the last time I had that phone on with location. So here are all the coffees. Right, so we can see the muffin is 35 kilobytes in size, whereas all the other ones are about 15. You know, there was an app for a football stadium in America, and they downloaded different pictures for Pepsi, Diet Pepsi, root beer, and they all just looked like cups with brown fizzy stuff in them. Like, there are times where you can reuse the same image, like Diet Coke and Coke kind of look exactly the same. I don't know. That's a sort of simple performance thing that doesn't really require a lot of thought, at least to me. But anyway, you know, those are all being downloaded here. It looks like at 187 seconds. So anyway, we can see a lot of what was going on. Oh, here's some more big images. This is gonna be more food. Again, those weren't sent by HTTPS. No need to. That makes sense. Here's 115K. What do we have here? Oh, didn't completely download. I stopped the trace before that one. So you can see the file's 115K and only like 64 was downloaded. So anyway, that sort of gets you an idea behind what you can do with Arrow and the sort of things you can see. It's a pretty powerful tool. In a couple months, we'll have HTTPS, so we can see all the stuff that's going on behind HTTPS, like are you caching those files correctly? Because that's important to look at. We also want to do some security stuff because I've seen some really crazy stuff go by in HTTP headers, like my password. You know, things that you shouldn't send in there, my location. There was an app that I was testing for a while, and then I forgot about it, and I went on to other things, and I was testing another app, and I saw this app fire up every 15 minutes and send my lat long to some third-party SDK. And the third-party SDK is like, well, it's not, it's anonymized. And I'm like, not if you know where I live, and you know where I work, and you know where my kids have soccer practice between 5 and 6 every single night. Right? It's not anonymized when you know that no one's at home between 5 and 6 every single night. I uninstalled that app. But you know, if you're building applications, you should look to see what the third-party SDKs are doing with your customers' data, because eventually it all falls back to your app, whether or not it's the SDK that's collecting the data or it's you. You should look to see exactly what those apps are doing. Oh, and look, it went back to the beginning of my deck. Isn't that really convenient? All right, so we'll come back. Live demo. Not too far. All right, live demo. So my computer hates me today. All right. So automated testing. You know, one thing that we do a lot of now is we do automated tests. Make sure that your app isn't crashing. You know, you build, you know, we can automatically test websites and things and load them, but we want to do the same thing with Arrow. And so part of our 5.0 beta is we built these are the command line controls to start and stop Arrow, but we also have a Java API that you can start and stop Arrow. And so the great thing about this is if you have a test built, all you have to do is call that first one, that's start collector, the VP and Android, and then you say where you want to save it and if you want video or not. And it will start the Arrow trace, and then it can run your automated test, and then you can stop it. And then you have the trace run. And I'd be happy to do a demo of that if you guys are interested. Anyone want to see that? Or it's the same idea. I just do it from the command line. And then you can do automatic analysis. So you can make it an HTML document or a JSON format that you can take into a different database and parse it and figure out how your app is doing over time. You can compare traces from time to time, see if the build you just submitted is better or worse than the one before. And therefore, you know, we've seen this with people not doing audit, you know, without testing their app, is that they do a lot of fixes and then slowly it gets worse and worse and worse and worse and worse. And then they look at it and then it gets better and then it gets worse and worse and worse and worse and worse. But if you have this built in now to your testing, every time you do a native build, you can go and see if your application is doing better. Again, if you guys are interested, I'd be happy to do a demo, but it's sort of the same idea. It's just run on the command line and it starts the Arrow as opposed to me doing it manually. It's pretty cool. And that, I skipped some slides there, so just give me a second here. I'll figure out what happened here. I'm gonna blame my kids. So other things that you can do, like, so if you're interested in HTTPS content now, like you can use Charles Proxy or you can use Man in the Middle tools to look at how your app is. Yeah. Mm-hmm. Mm-hmm. So if you're trying to get in there with like a Charles Proxy, it won't be in. So what we'll do with the Arrow is have something very similar to the Charles Proxy thing. There may be ways around it. I don't know. I'm sure there are. But yeah, so that's one thing. At the big Android barbecue in Texas in October, there was a talk where somebody was talking about Arrow and how it was one company, how they test their competitors with Arrow because they want to see how their app is doing compared to their competitors. So you can do that, but again, if the certs are pinned, you can't get in there. The other cool thing you can do with Charles Proxy that I think is a really great thing is the ability to throttle. So you can go in there and you can set the throttle setting to like 768 kilobits per second and to see what your app looks like on that'd be like a slow 4G, a fast 3G network. It's pretty eye-opening to see what your app looks like on a 2G, like if you cut it down to like 184 kilobits per second to see what your app looks like. It's pretty slow. And when you start thinking about how a lot of, if your application is looking to go, like at the meeting last month, it was the BBC. They were talking about how the BBC has to run in all these different countries, and they don't all have 3G. Facebook has launched their Facebook Lite because the Facebook main app doesn't run as well in some of those other countries. The Facebook blog talked about how the first time they sent a bunch of people to Ghana and they bought devices and they bought data and they blew through a month's worth of data in like 40 minutes. It might have been 25, but it was insane. And then they did this similar thing in Indonesia, and they realized that like 20% of all of their data in Indonesia was going through a CDN in South America. And that's through Tokyo, I think. I think to go from South America to Indonesia, you have to go up through, it's not direct by any stretch of the imagination. So looking at how your app runs on a slower network is a pretty powerful thing to do as well. I'd recommend you do that. Web page test does that. You can set the speed in web page test if you're doing mobile web. Also a really good thing to do because it's really easy to forget when you're in London or you're in Seattle or you're in the Bay Area that, like I said, not everybody has 4G. Not everybody has a device with like 4 megabytes of RAM, or 4 gigabytes of RAM, or 16 gigabytes of storage, or whatever the heck it is, right? I mean, people are very resource constrained on their devices, so it's good to think about those sorts of things while you're building your app. So that's not the deck I want. Where is it? Come on. I'm winning at PowerPoint today. All right. I did the live demo, automated testing. Oh, okay. So here's how you could integrate into your CI testing. So if you have an automated test and you can start and stop it in just, bookmarking your automated test, all of a sudden those reports will now have your performance data in there. That's kind of how we're looking at it for right now. We will have the APIs are released as our beta. It's on our website. We'd love you guys to check it out and give us any feedback if you're interested in this sort of stuff. We are actively going to have this push to production to our 5.0 release in the next month or so. We're really excited about that because hopefully that will help people do a little more automated performance testing on native stuff. HTTPS, I've talked about this a little bit with Charles proxy or man-in-the-middle proxy to decrypt all the data and see what's going on. I was just playing with that earlier today and I could see all my passwords and stuff. I don't want to do a live demo of that because I'll accidentally show you guys all of my passwords. But like I was testing the Airbnb app and I could see all my reviews, and like, it was really kind of cool to see all that information going back and forth on the network. It's a little weird because I haven't had any new reviews made for like us staying in Airbnb since the last time I used the app. So why is it download? Shouldn't it have cached it and not downloaded that file? But it's also been a couple weeks, so maybe they just refreshed it. Maybe it expired. So all of those things are coming soon to Arrow. We're also going to build a network throttling tool in there so you can run a network test, run a trace, and actually slow down the network while you're running Arrow. We're pretty excited about doing all those things. I mentioned briefly that some areas of the world just don't have the infrastructure or the technology they don't have 3G, they don't have 4G, so it's useful to test on networks that are slower. And so, in closing, if your app is slow and moving really slowly and you work to make it faster, your customers will be happy, you'll have more engagement. People have found, we all know that people buy more stuff when the app or the website is faster. And hopefully your app will be as fast as my dogs as they're running down the beach on Whidbey Island, north of Seattle. So with that, I'd like to thank you all for listening. And if you have any questions, I'd be happy to take them at this point. Yeah.
Yeah, thanks for the talk. Great. That. I just had a question about the way that you make the capture. So you're using a VPN, right?
Yeah.
So
That's
you said earlier that you're not capturing the other like traffic coming from the phone, but so how are you scoping that down so that only that app goes through that VPN?
All the data goes through.
Oh, okay.
So if you and that's how I was talking about the application where I saw this other application firing up in the background and sending off my lawn every 15 minutes. At first, I thought it was the app I was testing, and then I realized that it was a different process that had fired up and was sending that off. So yes, if you're using a phone that has Facebook and Twitter and your corporate email and your work and your personal email and all that other stuff, you will see all that traffic as well.
Is there a way to scope that down then in Arrow, just to say I'm only interested in my traffic?
So there is some cool stuff in. So with the version that uses root, we actually get the process names on Android. So we can know which one is Facebook, and we know what's Twitter, and we know what's email. And let me find it. Here's Arrow. And so you can see here it says application. I don't know. You might not be able to see that. It says unknown here because I did that with the VPN. But on one where it's the other thing, it will say, this data was from Facebook, and this data was from Starbucks, and this data was from Domino's. And then you can actually go in and you can select the applications and IPs, and you can remove the applications you don't want to see. If like if you can sort all these and you know that you don't want, any of these Amazon IPs from like this AWS range right here, you can turn those off and remove them and not look at them. Or if you just want to look at a few IPs, because those are the ones you're interested in, you can remove all the other traffic and just look at one IP address if you're really interested in that. And just, take away all the other, if you wanted to take away all the Starbucks images, but look at something that was underneath those, you could do that. So we can add and remove that traffic.
Right, you must have answered everything, Doug. Yeah. Anyway, so what's Andrew? Is he not that Andrew? The other Andrew? Did he skip out because he's got some big news to tell everyone? But I don't know if you saw his tweet from today, but Andrew Betts got taken on the W3C tag committee today, so that's really great news for him. So. Congratulations to him. I'd like to congratulate him in front of everyone, but he's gone. So right. So any other final questions before we kind of basically move on to the beers and just wait for the pizzas to turn up and have a chat? No? Anyway, okay. Well, that's great. Well, thanks everyone for coming again, and keep an eye out for the announcement for the talk in February. Mm-hmm. It's probably not going to be the first week in February. Again, like the second week. It's all going to be dependent on when Tim actually arrives in the country. So we're kind of working on that one, but there will be something around that time. I'm sure that'll be a great meet up too. Oh, is he around the corner? Ah, here he is, back again. I was just telling everyone about your tag appointment. So just so everyone knows. Yeah. So when you want to complain about the standards and stuff, you now have got a man to do it to. But there you go. So anyway, so that's about it. So enjoy the beers, and we'll see you all again next month. And enjoy the pizzas when they turn up. All right. Thank you very much.
Thank you, everybody.